There's one more topic related to construction that we have to talk about before we move on and next week talk about the next level of object-oriented programming. And it's something that I've brought up a few times over the past few videos, and actually we have sort of accidentally covered a little bit of it so far. And it's the issue of how objects get copied. So of course, with this idea that when we define a class, we are in complete control of when the objects are created and how they get and what happens when they get destroyed, we care obviously about cases where objects get created by being copied from other objects. So we know already, of course, I can write constructors that take arguments and then construct the object based on that. But we've also seen that it is permitted to copy one object into another. So if I have a point object, I could assign the value of one point object to another. That's a form of copy. I could also create a point object to equal a copy of another existing point object. So there actually are two different cases already we can think of. Cases where I copy an object to create a new one, cases where I copy one existing object into another already existing object. Those are two separate things. One of them is a construction, one of them is creating an object, one of them is basically just assigning from one object to another. We've already seen in a previous video that we can write assignment operators, and in fact we're going to see a couple of those now. So this is going to cover, first off, the idea of what's called a copy constructor and copy assignment operators, which is, I think, the last piece in the puzzle over how we have complete control over an object's lifespan. How does the object get created, including times it gets created by being copied in from some other object. We know that there are some types in our language, including stdostream, the type of cout, where copies aren't allowed. So we need to know how to govern how a copy is made, so we have the option of prohibiting it if we want to do so. I'm also going to talk about some advanced crunchy technical stuff that is above the level of this course. I'll give the signal when you can start ignoring that material if you don't care about it. I feel like although the technical stuff at the end of this video that will not be on exams. Some of the stuff in the video will be on exams, but the stuff at the end won't. Although that technical stuff is above the level of the course, it might help to hear a little bit about it because it might help better. It might help you build a better conceptual model of what the language is really doing. But maybe just knowing about it recreationally. Don't worry so much about understanding it for exams and things. So what I have here is my trusty point class, making I think its last appearance of the week, although we're not done with the point class in this course. And it's got the usual constructor. So I've got my constructor to take an x and y value. Notice how now that we know about the this pointer, if I want to print out the point, I can just push the entire point object into my output stream. So of course the type of star this is point. I can just push into my output stream because I have an operator that can do that for me. My default constructor, which I provide, just defers to this other constructor. I've got a destructor that does basically nothing besides print the object out. And now something new. So what I have here is what's called a copy constructor. It is an ordinary constructor that takes as its argument an object of the same type that I'm constructing. So in this case, a reference to a point object. Maybe you can think to yourself, given that I'm making this is the constructor that governs how to make copies, it would be a bit bizarre to have the argument taken by anything other than reference. If I tried to take the argument by copy, I'd get into sort of circular logic situation. So this is what's called a copy constructor. And although this is the first time we are seeing one written down, we've actually been using them over the course of the week a few times. It turns out the compiler provides for free default versions of a lot of constructors and things if you don't provide them. So because you often do want to make copies of objects, we have seen this week that we could have written P equals Q for points P and Q. Because you often want to do something like that, the compiler understands that if you don't provide your own custom copy constructor, it will provide one for you. A free default copy constructor will be provided. When the compiler provides a copy constructor for you, the one it provides just copies every member of the other object into this object. That's all it does. We call that a shallow copy. Just make a photocopy of each member. Now the one I've written does the same thing, but it prints some output. So this is actually a pretty basic copy constructor. Except for the output, I could just leave this out and the compiler would generate one for me. While we're on the subject though, if you don't provide your own destructor, so I could just delete this, it turns out every class has a destructor. And if you don't provide your own, the compiler makes one up for you. The one it makes up is just empty. So if I don't provide my own destructor, the compiler would provide this one for me. And now that's a bit of a technical point. Why do we care whether it doesn't provide one or provides an empty one? I think it's sort of, I don't know, comforting to know that there is always a destructor, and if we don't have one, the compiler will have one, so therefore we can guarantee that a destructor always gets run. The same is true of constructors. So if I provide absolutely no constructors whatsoever, the compiler will provide one free default constructor that looks like this. It'll be blank. It will do nothing. It will initialize the members with their default constructors and then do nothing. And so if I don't provide constructors, the compiler looks at that and says, well, if without constructors you don't have a class, you couldn't create this object, so I'll make you a free one. And if I provide any constructors, so for example, if I provide this constructor only, the compiler interprets that as me saying I don't want there to be a public default constructor. So it does not make me a free public default constructor if I provide any constructors of my own. But if I provide no constructors, it gives me a free default constructor, with the understanding that I guess I wanted the compiler to do that for me. And if I do not provide a copy constructor, it gives me a free one. But here I've defined my own copy constructor, an ordinary constructor that takes as its argument a reference to another object of the same type. By the same token, there is what's called, what I'm going to call at least, a copy assignment operator. So the copy constructor is used in cases where I am making a new point object using an existing point object. But there's also the case like this, where I write literally P equals Q. What if P and Q already exist? Well, if that's the case, it's inappropriate to call a constructor, because once the object already has been constructed, you can't construct it again. And so on line 47, I have defined what I'm calling the copy assignment operator. It is a special case of the single equals assignment operator that on its right-hand side takes an object of the same type. Just like a copy constructor, if you don't provide one of these, the compiler gives you a free one. It assumes you do want to make copies of your objects like this, and it just gives you a default single equals operator that can copy an instance of a point into another instance of a point, a shallow copy. And so this is the operator that we would use in cases where the two objects already exist. This special case where y is a non-temporary object, that is one of those things that gets into the technical material I'm going to cover at the end. I'm going to skim over what I'm going to need for that right now. There are also these two rather esoteric forms of constructors or copy operators called the Move Constructor, which is used in cases where I'm creating a new point object using an existing point object, but that existing point object is doomed. It's about to be destroyed. So this point object will not survive the copy operation. In that sense, it's not really a copy, it's a move, and I'll talk more about that in a few minutes. And so we have what's called a move constructor. Now, besides the fact that this seems like splitting hairs, there is something else that is very unsettling, which is the existence of two ampersands right next to each other. So I know that's scary. Try not to look directly at it, but be comforted, I guess, by the fact that this is not a type you're going to see in the middle of code. Although there are cases in C++ where you can have an argument to a function that has two ampersands in it, it actually is just a regular reference for all intents and purposes for us. It's not some weird double reference thing. It's just strange notation to signal to the compiler the meaning of the reference that you want. So we're not going to see it. I don't think we're going to see it again in this course, except maybe by accident. It's not something we have to, it's fortunately, unlike a two-star pointer, not something we have to learn as a special thing. So my move constructor is if I'm making a copy of an object where the other object is about to be destroyed, and my move assignment operator is the same situation where I'm doing something like x equals y, where x has already been constructed and so has y, but y is about to be destroyed. And I will explain that further in a couple of minutes. Okay, so those are the forms that I want to talk about in the video. Down in main, actually before I get there, I have this function here called makeAPoint, which takes an x and y coordinate, creates a point object, and then returns it by value. So it wouldn't make sense to return it by reference because it's a local variable, but it returns it by value. So in a sense, we can think of it returning a copy of this object a point. Okay, so that's what the makeAPoint function does. Okay, here's main. So in main, I create 2 point objects, and as of line 104, they have both already been constructed, so I can't construct P and Q again. And then we run through a few use cases. Okay, so I'm going to try compiling this, and we can see for once, the compiler actually has an easy time of it. So I try then running it. And I'm going to scroll up. There's a lot of output. I'm going to go through it piece by piece. So we can see I construct my points 6, 17, and 10, 187. So that's P and Q right there. Then I get into part A. So part A, I think, is an obvious use of the copy constructor. I am constructing an object of type point. There it is. There's my declaration. And I call the constructor with curly brackets, and I pass in an object of type point. And of course, we go looking for a constructor that takes an object of type point, and we find our copy constructor. So it shouldn't surprise us, this calls the copy constructor. Now, as I said earlier, whether or not I provide my own copy constructor, if I don't provide one, this is still allowed. The compiler provides me a free one. If I want to prevent anybody from copying my object, I can do that. What I do is define my own copy constructor and then make it private. And there are a couple of shortcut notations for that. But basically, if you define a copy constructor and make it private, there's another notation you can use that we can think of as deleting the copy constructor. You can prevent anybody from copying your objects. If the copy constructor is private, copies aren't allowed. You have to make sure you make all of the different copy operators private for that to work in an airtight sense. So on line 106, I am calling the copy constructor. So what about line 111? I'm going to come back to line 108 in a minute. On line 111, this is sort of neither here nor there. I guess I could be using an assignment because I have an equals sign, but I'm also declaring an object. And if we think about this, this is actually just a C-style initialization, which all semester I've been saying, don't use C-style initialization, use this. And here, once and for all, I can prove to you that the compiler views this as being indistinguishable from this. When you write point B equals P, the compiler reads that and says, oh, that's a C-style initialization. It's not an initialization followed by an assignment. It's a C-style initialization. So we're going to rewrite it as this. So, okay, if they're equivalent, why have I been insisting on using the version on line 106? Well, one reason is, how do I give constructor arguments for this style of initialization? Well, I don't know. And also, there are some cases where this can cause other forms of confusion. So we should always use uniform initialization. But to be clear, if you do a C-style initialization, so you declare the variable on the same line as an assignment, you are actually just calling the copy constructor, when the thing you're assigning is a thing of the same type. And we can see that in part B. It's just calling the regular copy constructor. So that begs the question, when am I going to use the equals operator? And we'll go down to part C and take a look. So on part C, if I look at part C, on line 114, notice that both objects I'm using already exist. They've already been constructed. So it would be completely inappropriate to call a constructor for either of them, because you can't construct an object twice. So in this case, on line 114, I would call the copy assignment operator. I'm making a copy of P into Q, but I'm doing that via an ordinary assignment. So that would call my copy assignment operator, the one on line 47. Here we go. And so we can see it prints out copy assignment operator. Okay, so those are the three cases we care about in this course. In this course, on an exam, you will be expected to understand what a copy constructor is, when it gets called, and what the copy assignment operator does. The other things I'm going to talk about after this point might show up at some point on an assignment sort of by accident in the margins. They might show up, but they're not examinable. So you might have to write them, but you can come back and watch the video then. Don't worry about studying those for an exam. So if you're fed up, now's a good time to bail on the video. So what are the other cases? And again, these are above the level of this course. They are pretty technical. A higher level course in C++, so a plug I would put in for that would be Software Engineering 475. We'll have lots and lots of fun with these features. It would definitely talk about features like this. So what about, I'm going to just scroll here to show this whole thing. Let's look at part D. So there's this long comment here. I'll try and unpack that. In part D, I'm also doing a construction. So I'm creating a new point called D, and I'm providing as my constructor argument, we'll scroll up a little bit, the return value of make a point, which is of type point. Make a point creates a point object and returns, I guess, a copy of it. It returns it by value. And so in part D, what I'm doing, I'm going to see if I can draw myself a little diagram as a sketch here. In part D, I appear to be almost calling a copy constructor because the thing in the brackets is a point object. So it seems like a good opportunity to use a copy constructor, but something rather unsettling happens instead. So what am I doing on line 131? Okay, I'm inside of main, and I'm trying to create this object of type point called D. Okay, and so I call the function make a point. There it is. And inside the function, I make a variable, and the function calls the variable a point. And it also has type point. And the function returns this thing. And of course, when the function returns this object, it's doomed. As soon as it gets returned, it gets destroyed. And so here's a case where maybe it's worth having a special situation, because what I'm really doing here is, it could be viewed in two ways. I could either make a copy, go through all the effort of copying everything out of here over there, and then erase this, destroy it, and then construct D, run the copy constructor for D in the process of doing so, which is a lot of work. First, I have to perform a copy and then delete a bunch of data. Alternatively, I could say, wait a minute, I want to have D be whatever's in this object. And this object is doomed. I'm never going to need it again. Why don't I just pick up the entire thing and bring it over? Just bring the entire thing over. That's a special case. I'm not making a copy in the traditional sense. If I scroll up, and please forgive the diagram conflicting with the text, if I scroll up, recall the last time we used a copy constructor, the last couple of times we used it, on line 106, I construct A to be a copy of P. After I'm done, P still exists. I don't go and destroy P afterwards. And on line 111, same thing. P still exists afterwards. After I'm done the copy, the two objects that were concerned now exist concurrently. That's not happening on line 131. On line 131, I know the thing on the right-hand side will not exist after line 131. It must be gone. So the question is, what do I want to do? Do I want to do a full copy of the thing over here into D and then do the destruction sequence for this, which might take some work, or can I save the labor by just picking this thing up and bringing it over to main? So I don't make a copy, I move it. And once I've moved it, I don't need to destroy what was left because I moved it. And then unfortunately, it doesn't end there. The language gives the compiler two ways of moving the object. So in cases where I'm making a brand new object out of something that the compiler knows will cease to exist after the end of the line, the compiler has the option of moving the object instead of copying it. And there are two ways this can happen. One, you could call the move constructor. I could hand the object over to the move constructor and tell the constructor, now move the object over into D. Construct D to be the result of moving everything out of this function, make a point. Or the compiler can take control and not even give the class that option. And this is one case where the compiler actually butts in and prevents the type from having the full control that we normally expect. In this case, the compiler is allowed to just say, hey, I know you're making a move here. So what I'll do is just pick up the object, move it over to main, and then we'll be done with it. That's it. I won't tell you at all. I will not run any constructor because the object will just silently and seamlessly move into main. I'll just extend its lifespan. So instead of being destroyed at the end of the function, it now just comes and joins the family here in main and gets destroyed at the end of main like every other variable in main, in the normal lifespan of the variable D. And so that means that the variable in the function does not get destroyed because it just got moved. Its lifespan is not over. This is called copy elision. And that's one of those technical crunchy terms where if you see that in something about C++, you know that you've gone pretty far down the rabbit hole of weird technical stuff. Copy elision. What's weird about this isn't just that the compiler has this option of doing nothing and just moving the object around without telling you. It's that it's an option. The compiler doesn't have to do this. It can choose, will it call the move constructor or not? And we'll notice in this example, it didn't. So in part D, inside the function, I construct my object 999888. That would be this constructor on line 95 as a result of the function call on line 131. And then I just get to part E. I don't see any destructors getting called, and I do not see any copy constructors or move constructors. The compiler used copy elision. And it's pretty likely, if you pick up some other C++ compiler, that it would use that here too. Copy elision. Now, be fortunate, you do not have to worry about copy elision on an exam. That's one reason this is not examinable, is because of the uncertainty about exactly what happens here. It's a very rare case where the language, we've gotten far enough down the rabbit hole that we're seeing the places where the language standard gives compilers some authority to make their own decisions. The reason why that authority is given is because the compiler can judge whether doing the silent move is going to be faster for the code. And that might be something that can optimize code, especially very complicated programs. Okay, one more case. Where are we going to use those move operators? Well, let's look at part E. So part F is empty. In part E, I construct a point object. So unlike part D, where I'm making a brand new point object out of something that is doomed, and so I can just recycle the doomed object to become D. In part E, I'm not doing the same thing. In part E, the point named E already exists. On line 151, I am running the function makeAPoint, and then I am assigning the result, and to be clear, the result is still doomed. The makeAPoint function is going to end, and the thing inside makeAPoint will cease to exist. But I'm assigning it to a variable that already exists. The variable E already exists, and of course I'm not allowed to construct it twice. And so what I'm doing on line 151 is an ordinary assignment. And that is a use for the move assignment operator. So strangely, I wasn't able to show you a use of the move constructor because the compiler, via copy elision, took that chance away from me. But I can show you the move assignment operator. And we can scroll down and look at the output for part E. So here is the move assignment operator. This double ampersand notation, for our purposes, view that as a way of signaling to the compiler that this is designed to take an object that is otherwise doomed, some temporary object that would be immediately destroyed, that would I think it should say would be immediately destroyed. That I shouldn't even say would, I should say will. Sorry for the on-the-fly copy editing here. So the move assignment operator is what you use if you have an object on the right-hand side that you know is about to be destroyed. In this case, it is an object returned from a function. There are other ways you can create some temporary instance of an object on the right-hand side of an assignment. If you're assigning such a thing to an existing variable, so construction makes no sense, then you use the move assignment operator. And we can see here, this is the construction for E. Here is the construction for the point -10, 20 inside the function. Here's the move assignment operator. And then once I do the move assignment, I do still have to properly destroy the object in the function. So this destruction is of the object inside the make a point function, the variable called a point. And then down after part F, we can see all the destructors. So there's E, there's D, and then there are all the other ones. There's B and A, and I guess Q and P. So what we care about for this course is parts A through C of this. We need to know about copy constructors, copy initialization, and copy assignment. I think having some idea about the gymnastics the compiler can do with move operations is helpful as part of building a model of what the language does, but you won't be tested on understanding the use cases of move constructors or the move assignment operator.